let's look into multi-threading benefits as we left around in the previous session. So multi-threading benefits, where there are n number of benefits doing multi-threading in your code. Okay, so why we are actually doing multi-threading? First question is that, then what is the benefit of implementing multi-threading in the code, and why and where to change our code in order to implement multi-threading? So there are different questions arising in your mind. So let's move and see what are the benefits. The reason multi-threading is still used in spite of its challenges is that multi-threading can have several benefits. Some of these benefits are better resource utilization, simple program design in some situations, more responsive programs, and all these things that lead to the use of multi-threading more predominant. Okay, so what are all these terms what I have told you? Okay, that you should be aware of and you should know that what these terms are. So I will explain each of them. So what is meant by better resource utilization? Okay, so better resource utilization means that you are using your resource more efficiently. You are not blocking any resource for any particular work, or your resource idle, keeping your resource idle for some type of time. Okay, so that is called better resource utilization. Okay, so again, after better utilization, we have simpler program design in some situations. In some situations, when you have to execute multiple instances of the same program, you have to write complex code and you have to handle each of the situations. Just implementing the multi-threading model, you can achieve simple program design in some situations. And the programs that you will write will be more responsive than the previous one what you have already written. Then we have better resource utilization. Imagine an application that reads and processes files from the local file system. Let's say that reading of file from disk takes 5 seconds and processing it takes 2 seconds. Processing two files then takes 5 seconds reading a file A, 2 seconds processing a file A, 5 seconds reading a file B, 2 seconds processing file B, that is 14 seconds in total. So this is how, if no multi-threading is applied, it will take 14 seconds total. When reading the file from disk, most of the CPU time is spent waiting for the disk to read the data. The CPU is pretty much idle during that time. It could be doing something else. By changing the order of operations, the CPU could be better utilized. Look at the ordering. 5 seconds reading file A, that is okay. 5 seconds reading file B, that you can see was this third one, plus 2 seconds processing file A, then comes the processing file file A, and then 2 seconds processing file B. Okay, so this is how actually this is how actually the processing will be done. Okay, so from 5 seconds from 14 seconds we have actually moved on to 12 seconds minimal. Okay, so actually the time has reduced drastically from 14 to 12, right? So this is how we say about better resource utilization is all about. So we have actually managed to do the operations because the resource A was free till the B was processing, so it has done two at the same point of time. So because A was available and B was being read, so the thing what has happened is actually the time that was taking more, that was 2 seconds from the earlier two processes, has reduced from 14 to 2 seconds. So this is how the better of the resources has been better utilized in this particular part of the thing. Read the CPU process the first file. Remember, while waiting for the file to be read from the disk, the CPU is mostly idle. So while reading, the CPU will be idle, but while writing, it will be involved in writing into the disk. In general, the CPU can be doing other things while waiting for IO. It doesn't have to be disk IO oriented. It can be network IO as well, or input from a user at the machine. Network and disk IO is often a lot slower than CPUs and memories IO. So this is how actually we have made our time reduced from 14 seconds to 2 seconds by just thinking logically that when the CPU is free and when the CPU is not. So let's look into the simpler program design, how you can modify and make your program more simple and more responsive. If you were to program the above ordering of reading and processing by hand in a single threaded application, you would have to keep track of both the read and processing state of each file, right? If you have to think of which particular resource is free and which particular resource you have to write in, then you have to keep all the threads in action into a queue that would manage that which of the threads are being processed or read. Instead, you can start two threads that each just reads and processes a single thread. Each of these threads will be blocked while waiting for the disk to read its file. While waiting, other threads can use the CPU to process the parts of the file they have already read. So the result is that the disk is kept busy at all times, reading from various files into memory. This results in a better utilization of both the disk and the CPU. It is also easier to program since each thread only has to keep track of a single file. So the main operation in where the resource is being occupied is being taken care, and then that part of time the CPU is wholly utilized to do what it is allocating the resource to, and after that it has no covered up all the things and it has made the resources free and make it usable. Talking about more responsive programs, another common goal for turning a single-threaded application into a multi-threaded application is to achieve a more responsive application. Imagine a server application that listens on some port for incoming request. When a request is received, it handles Imagine a server application that listens on some port for incoming request. When a request is received, it handles the request and then goes back to listening. The server loop is sketched below. While server is active, listen for request, process request. If the request takes a long time to process, no new clients can send the request to the server for that duration. Only while the server is listening that can request be received. An alternative design would be for listening threads to pass the request to a worker thread and return to listening immediately. The work thread will process the request and send a reply to the client. This design is sketched below. While server is active, listen for request, hand request to worker thread, and so on. So basically responsive means that your program will not end up falling in some conditions, or your program will not end up in a multi loop condition where it is going to be in a dead loop or it is not coming out. So it is not going to be in a such conditions. If you have programmed in a multi-threaded model, your program will behave in a normal and agonistic manner. So this is how actually your programs become responsive. So you just need to remember the points, no need to go into detail. Better resource utilization, simple program design in some situation, more responsive, and finally we will see this way the server thread will be back at listening sooner, thus more clients can send requests to the server. The server has become more responsive. Okay, the same is true for desktop applications. If you click a button that starts a long task and the thread is executing, the task is the thread updating the Windows button, etc., then the application will appear unresponsive while the task executes. Instead, the task can be handed off to a worker thread. While the worker thread is busy with the task, the window thread is free to respond to other user the request. When the worker thread is done, it signals the Windows thread. The window thread can then update the application windows with the result of the task, the program. The main motive what I want to say you is, when one program is being executed, it doesn't let the other program to slow down or calm down. The other programs are executing as well based on the resource utilization, and all the resources that are involved can be actually tracked in such a way that your resource utilization, your time utilization are actually increased to its maximum potential. So these are what we can have the multi-threading benefits from doing multi-threadings instead of single-threaded models in our programming.